Everybody, and welcome back to another fun and exciting pre-algebra class. Today we will be finally finishing up chapter number 7, right? We've been on this chapter a long time, and we'll be finishing up chapter number 7. We'll be in lesson number 9. That's on page 348. You can go ahead and look there. If you want, make sure you have a notebook out. Make sure you're taking notes as I'm going through this. And, learn with me. How do you learn with me? Well, write things down. Use your notebook. Do the problems as I'm doing them. Write the words that I'm underlining. Write the words that I'm highlighting. Make sure that you know what's going on. And so be an active learner as we go through this lesson. And that will really help you when it comes time to take your test. Okay? So let's jump down here. Look in your book, or you can look down here at the screen as well. I'll put it here. Today we're going to be talking about rotations. What is a rotation? Most of you are pretty familiar with this actually because you do this on the computer a lot. For instance, you'll put a picture on the computer and then you hit the little button that has a little arrow. It's like a curved arrow, right? You hit the button and it turns the whole picture, okay? So it turns it 90 degrees, typically. One click, 90 degrees. And usually it goes 90 degrees, what's called clockwise, okay? So it goes the way that the clock goes, or then you could go counterclockwise or clockwise. But typically it's going to rotate in a clockwise direction. So what does this mean in coordinate geometry? Well, it really means the same thing that you do on the computer with your pictures. Rotation turns the shape around the center of rotation. What is the center of rotation? Well, it's whatever point you're rotating the shape around. Now, that can be different. You could use the corner of the shape. If you rotate the thing around the corner of the shape, then it just spins on one corner, for example. But for this book, for this unit, for this class, we will only use origin 0, 0 as the center of rotation. We're just going to use 0, 0. It'll be easier that way. When you get into maybe some of your more advanced classes, your geometry classes, things like that, they may do different things with rotations to show them to you. But for this class, we're just going to rotate around 0, 0. It's going to be hopefully easy for you to understand how to make that happen. So there's different types of rotations. Really, there's 3 different types of rotations that we can make. And there's more rotations. I mean, you could do a 1-degree rotation, so it's just moving a little bit. But there's 3 types of rotations that we're going to be using here in coordinate geometry. The types of rotations are, number 1, the 90-degree clockwise rotation. I've put the letter A over here, and what we're going to do with the letter A is we're actually going to rotate the letter A around. The first one, obviously, is what the letter A looks like. Normally, when you write the letter A, that's what it looks like. The first one I have rotated 90 degrees clockwise. In other words, you take the letter A and you turn it 90 degrees in the clockwise direction. And it would look something like that. The second type of rotation is a 180-degree rotation. With the 180-degree rotation, you would take it and you would not only rotate it once 90 degrees, but you would then rotate it again another 90 degrees. So it's 90 plus 90. And then the shape is standing on its head, basically. Okay? It's upside down. Once you get it into the upside down, you could do what's called a 90-degree counterclockwise. Now, one way to think of this is a 270-degree clockwise, right? Because you do a 90. 90 plus 90 is 180 plus 90 again. So this one would be a 270, and that's counterclockwise. So what does that mean? Rotate, rotate, rotate. That's like 3 rotations. So you could see this. If we rotated this one again, you would come up with this one. Now, that's one way to think about it. The way that the book tells you to think about it is instead of that, let's go all the way back up here to the top letter A. All right, so let's go back to this one. What if we just turn this top letter A one time? one rotation, 190, what's called counterclockwise, or the opposite direction that we moved the first one. Okay, so we go in the opposite direction. What would happen? Well, we would be right here in what's called the 90-degree counterclockwise. Okay, and I put maybe some helps for you here if you're kind of having some trouble with this. I said think of 15 minutes on the clock. So the hand moves 15 minutes, right? Then with the 180, you can think 30 minutes on a clock. And then with the counterclockwise 90 degrees, you think 45 minutes on the clock, or you could think 15 minutes backwards. Okay, so going in the other direction, 15 minutes. However you think about that, I think hopefully I'm making sense to you, and you're getting this, and I think most of you are because you've done this with photos on the computer, things like that, so you understand what's going on here. All right, now how are we going to make this happen in coordinate geometry? So on the Cartesian plane, how are we actually going to make this happen? Steps for rotations on the graph. Number one, if you have a 90-degree clockwise, that's your rotation that the book tells you to make, that your test tells you to make, whatever. How are you going to do that? Well, really, there's kind of two steps. Step number one is multiply the x-coordinate by -1. Whatever the x-coordinate is. Let's say that your x-coordinate is 1, 3. Those are your coordinates. So what you would do is you would multiply this by -1. So what do you get? -1 times -1 is -1. Notice then it says, then swap the x and the y. So if it was 1, 3, it would become 3, -1. So we swap the x and the y, and then we multiply that by negative. So that gives a -1, and then we swap those. Okay? And then when you graph this, okay, it's going to give you the rotated shape. And you have to do that by all of the points. You can't just do it to one point, right? So you have to go all of the points and do that, and that will rotate it along. What are we rotating? We're rotating it along the origin, along the 0, 0. Next, for the 180-degree rotation, here's what you will do. Multiply both the x and the y coordinate by -1. Notice it says do not swap that one. We don't switch the x and the y. We just multiply them both by -1, and it will rotate it 2 spots. Next, for the 90-degree counterclockwise, or for the 270 clockwise, however you're looking at that, you would multiply the y coordinate by -1. Okay, so we did multiply the x coordinate. So in this case, the y coordinate is 3. Multiply that by -1 gives you -3. So that would be 1 at -3. But then it says swap the x and the y. So we would have to take that -3, 1 would be the way to swap that for a counterclockwise 90-degree rotation. Okay. All right, let's try it. Let's practice this and let's see what happens right here, okay? So let me blow this up just a little bit. Let's switch over here to a little bit of graph paper and let's make this happen. Let's see what we can do. Let's first of all put our shape on the board. This is actually going to give us a triangle, right? Because there are 3 points. There's 3 vertexes, 3 vertices is how you would say that. And so there we go. Let's go ahead and put our triangle onto the graph paper. So the first one will do the yellow point 2, 3. So we're going to go 1, 2, and we're going to go 3, 1, 2, 3. So our yellow point will be right there. That's the first point they gave us. The second point that they gave us, and this is, if you're wondering, this is on page 348 in your book. So you can follow along in that example, example 7.9a. The B coordinate is going to be 6, 7. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 right up here at the top. And then we would do C coordinate, which is 4, 1. So 1, 2, 3, 4, and then 1. And there's our triangle right there. Okay, so let's connect the dots in. We'll make this guy green. So connect these dots and we get our triangle. Now, This is where the lesson starts. We've been doing that for the last week or week and a half. So we've been doing quite a few of those. Now what we want to do is we want to take these and create, remember we want to create new rotated coordinate points. How are we going to do that? Well, what does this problem tell us to do? Notice example 7.9a says to rotate the shape clockwise 90 degrees. So we're doing 90 degrees clockwise, okay? And so what we need to do is we need to really go back up to our steps, don't we? Okay, I marked all over these steps, but the first step was multiply by -1 and then swap. Okay, so that's the way that we do these 90 clockwise. Multiply by -1, then swap. So the new yellow one is we're going to multiply the x by -1, so that's going to give us -2, but we're going to swap them, so we're going to get 3 comma -2. That's our new point. So let's call this actually like, so we'll call this the old, and we'll call this the new. Okay, so this is our new point. Our new point is going to be 3 -2. How did I get that? Okay, I took the x point, I multiplied by -1, I got -2. There's my -2. Then I swap these, I switch the 3 and the 2, and I get 3 -2. Next one, let's do the blue point, the B points. So the 6 becomes -6, and then I swap those, so I have 7 comma -6. And then I'll do the pink ones, and I have -4. Swap those, I get 1 comma -4. All right, so there's my new points. Let me actually switch this where I put old. I'm going to put old in green, so you'll see that that's obviously the green triangle right there. And then so the new triangle I'm going to make purple so that it will look like the new triangle, so you can see which one's which. Okay, so let's do our new points. 3 -2. So let's go over here to our graph and let's do 3, 1, 2, 3, -2, 1, 2. All right, there's my 3 -2. And then we're going to go to the blue point, and the light blue point is 7 comma -6. So we're going to go 7, 1, 2, 3, 4, 5, 6, 7, -6, 1, 2, 3, 4, 5, 6. There we go. I'll put a point right there. And then we'll do the next one. The pink point is going to be 1, -4. So there's 1, 1, 2, 3, 4. There we go. All right, so there's our points, and now I'm going to take my purple line and I'm going to connect those points to make my triangle. All right, now what we have done is we've taken that shape. Now, hopefully you can kind of like wrap your mind around this right here. But we've taken that shape and we've rotated it one rotation. The purple shape is one rotation, 90-degree clockwise. All right, and we're rotating it around this origin point right here. Let me show it to you. Let me kind of pull this down here, and I think you'll see it. So what I'm going to do is I'm going to rotate it 90 degrees. Okay. And then I'm going to pull it down, and it should be sitting basically right on top of the other shape. And that's really close right there. Okay. So there's our rotation, 90 degrees, and then it obviously rotates. Remember, it's rotating around the center point. So we're going to rotate. Every time we rotate, we're going to be rotating into a different quadrant. All right, I want to show you one more thing, and this is actually not in this lesson. It was in, I think, lesson 7.7 maybe. It was a couple lessons ago. But I want to show you this before we really move on from this, because you need to know this, because they're going to start asking you questions about this. So here's what it says. It says superposition. Well, we haven't learned superposition yet. Well, we're going to learn superposition right here, okay? So what is superposition? Superposition is the process of showing that two shapes are congruent. Do you remember what congruent means? Congruent means same size and same shape. If you want to prove that two things are the same exact size and shape, here's how you do it. use a rigid transformation or a combination of rigid transformations. What do I mean by that? Use rotation, use translation, or use reflection. And you're moving the shape, and then you move it on top of the other one. So notice what it says, put it directly on top of the other one. Notice what I did up here, right? When I rotated this shape, the green one landed right on top of the purple one. They laid right on top of each other. Okay? What does that mean when that happens? That means that they are now in what's called superposition. Okay? Notice what it says down here. If all the points line up, every single point. What if you have a shape and one point is weird or one point's different? Well, then it doesn't count. If all of the shapes line up, then the two shapes are congruent. If they do not all line up, then the shapes are not congruent. Okay? So that's one way that you can prove congruency, is to line the shapes up on top of each other. If they do line up on top of each other, then you have congruent shapes. If they don't line up on top of each other, then not congruent. Okay? So hopefully you learned something there. That's all I got for you in this lesson. If you missed anything, make sure to slide that thing back, watch it again, practice some of these, go through these, and try to figure out how to make these different transformations, these rigid transformations, right? You're not changing the shape, you're just moving the shape into different places, whether it's rotation, whether it's reflection, whether it's translation, whatever you're doing. Okay? All right, that's all I got for you. Have a good one. Bye-bye.